Today we are actually going to talk about magnets, and we're going to see how magnets actually affect things around us, our machines around us, how the machines work. It's due to the force with magnets. Alright, so we're going to start first of all with the term magnetic force. And a magnetic force is that force of attraction or repulsion between two objects. So they're either two objects are going to come together, be attracted, or there's this force that's going to allow them to push farther apart so that they are not attracting. Okay, so let's look more specifically at a magnet. A magnet has particular properties. If you were to look at a bar magnet, and let me get one right here. If we look at this bar magnet down here, this bar magnet has a north pole and it also has a south pole. In fact, all bar magnets have that tendency with a north and south pole. The magnetic forces, again, they go from north pole to south pole, and actually a north and a south are attracting, and here you can see opposites are repelling. The strongest part of a magnet are located right here on these ends, located down there on those ends. That is the strongest point of a bar magnet. Alright, so now let's look more specifically at that attraction and repulsion that I just mentioned. So if I take two bar magnets, and we're going to look at those and play with those today in class. If I take two bar magnets and I bring them together, and if they want to stick and come together, then notice right in here what we have is that north and south are attracting to each other and they're being pulled together. Okay, and so that's showing that attraction where opposite poles are coming together. The repulsion over here, notice I have north and north, and they are aligned close to each other. They're actually pushing away. So in this diagram, it looks like the force is actually pushing it away and not allowing it to come together. So a north pole and a north pole will actually repel each other. Likewise, a south pole and a south pole. So if you have like poles, they're going to push each other away. Now, here's another phenomenon. What we have here is a bar magnet. Let's say if I take a bar magnet and I want to cut that bar magnet in half. Okay, come up here, let's just chop it in two. Basically, what I will end up are two parts down here. And what scientists have noted is that the North Pole and the South Pole will keep their tendencies, but the end down here will take the tendency of this one on that end, the south, and this one on the far left will take the tendency of the North Pole. Okay, so it's almost like if I break it in half, then what I have are two smaller and equal magnets. The same goes here. I'd split this one apart, and you have two smaller but equal magnets. Okay. Now, magnetic induction is basically taking materials that have elements that are found in magnets and trying to make them magnetic. A great example is a pair of scissors. Pair of scissors basically have iron in them. Now, iron's one of the elements found in very strong magnets. In fact, it's cobalt, nickel, and iron that are the three components that are found in strong magnets. Now, how do I take a pair of scissors and make them magnetic? What I'll do is basically have a magnet, as you see in this diagram here. I'll take that magnet right there and I'll let it touch or attach to that nail. That you can see in this diagram, they're using a nail, they're using a magnet. Let it attach to it, and then what you do is you stroke it down the length of that material. And the more times you stroke the material, the stronger that scissor or nail or whatever material you're using, the more times you stroke it, the higher the strength of it becoming magnetic. Now, here's a weird, funky word. It's called solenoid. If you open up any of your machines, a radio, etc., you will probably find a wire that's in there. And then you'll find these loops of wire around this. You'll find like a rod. There's a rod right in the middle. And then you will find these loops and coils of tightly wound wires around them. Now this mechanism right here does have the points on the end, and they're going to hook it up just like we hooked our wires up to a battery. And they're going to allow electricity to flow through that wire. And remember, it flows from negative to positive in our directions there. And what happens is, what is a neat finding is, when you hook the system up with electricity, that solenoid, this piece of equipment here, becomes magnetic. So if I put it near a paper clips or any items that are magnetic, it will it will attract those items to it, and it will act like a bar magnet. Now here's another term. Solenoids are also called electromagnets. So a simple way you could do this at home. So all you need is a coil of wire, as seen on this nail, and you wrap it around the nail. The tighter the wounds, the better. And we're going to find out as we increase the number of coils that my strength of it becoming magnetic increases. I can pick up more paper clips. So all you need for an electromagnet is a nail, wire, and a battery or power source. Okay? Now, increasing these electromagnets, you can see right here, there's your wires, there's your nail, and it's connected to it, to the battery. And then what they're doing is they're attaching this piece of metal, and it's attached to the nail right there. So if I want to make a material stronger, make a stronger electromagnet, what I'm going to do is increase the amount of coils right here that are wrapped around that nail. The more turns of the wire, the stronger the electromagnet. Now, if I want to let's do the reverse. If I want to make my electromagnet not as strong, take some coils away. All right, so these are some things you can find in an electromagnet. Electromagnets are found in motors. You have motors in almost anything, like your computers. You have them in your cell phones. You have motors in washing machines. Most machines around the home have motors in it. So what happens is they put one of these electromagnets in there, and they hook it up to electricity, and it causes it to spin. And that spinning creates mechanical energy, which will then turn into electrical into work for us. So basically, they're using the electricity that flows through there and converting that motor into spinning to produce energy. Okay? All right, so let's say the power goes out. Poof. All right, so here we have a motor. You got to have electricity to make it work. Let's say the power goes out. Okay, I want to create or make electricity. So when the power goes out, and it goes out for a long time, some people go out and they'll purchase this machine called a generator. Now, generators are usually bulky machines. They're expensive. And what they'll do is they'll crank it like a lawnmower. They'll pull a cord to cut it on. And then once it cuts on, then they can produce electricity. So it's like an electromagnet. So instead of using electricity to produce mechanical energy, in a generator, you're converting mechanical energy, like I'm pulling the cord to crank it open and converting it into electrical energy. And another one are transformers outside. If you look at power lines at the poles, power lines, you'll see this thing right here that is called a transformer. Well, inside they have this item right here, this core metal material, and they wrap wires around it. So let's say I'm going from a street and there's a lot of electricity. You can see right here a lot of electricity. So the more coils right there, a lot of electricity that's flowing through there. So it's creating a lot of power there, a lot of energy. So then what we have over here, then to come over and step it down, let's say from the street I want to eventually put that energy, that electricity into my home. I'm going to step it down, and the best way to do that is to decrease the number of coils, like the electromagnet. The less coils, the better. So in a step down transformer, we're going from the street to your house, and I'm decreasing the number of coils. But let's say energy, as we know, leaves our house and goes back out to that power line to continue on its path. We're going to step it up. So we're going to actually increase the amount of voltage. So we're going to take this image right here with the core, and we're actually going to flip it. So the small coils, we're going to try to tighten it up and have it move that way. So leaving it, you're going from loose coils to tighter coils to increase the amount of energy or electricity that's flowing through there. So our telephones, the electrical supply industries, all of those are examples of using the electromagnets. The last one, the fun one for you, speakers. You love your music, and you want to be able to hear on those speakers. What's cool about a speaker, it has an electromagnet inside, and it's in there, and they're using a permanent magnet that's inside with those coils, and it helps to increase or decrease the quality and the loudness of the sound. So that's why speakers are actually working with an electromagnet. Hope you enjoy. Hope to complete all your notes. That's it for today. Thank you.